Welcome to the Cambridge Tech Podcast, talking all things technology from the heart of the UK's tech capital. Here are your hosts, Faye Holland and James Parton.
Hi, I'm James and welcome to the show. Can you believe it's September? And what a busy month it's going to be. If you're a regular listener, you will know that Cambridge Tech Week is rapidly approaching. Visit cambridgetechweek.co.uk for the full breakdown of the schedule and to grab your tickets. Also, the application window for this year's Trinity Bradfield Prize has opened. As a quick reminder, anyone with an affiliation to the University of Cambridge is eligible to apply. You can be a solo application or part of a team covering either tech or life sciences. There's a range of cash prizes totaling £30,000, mentoring, free co-working space, and of course the opportunity to boost the visibility of your venture and to meet investors. A number of previous winners have gone on to really great things, for example SparkCell, and everything you need to know is on trinitybradfieldprize.co.uk, and the applications close on November the 30th. Okay, on to this week's local tech news. AI avatars designed by SKC Game Studio in Haverhill are helping to transform patient outcomes across the NHS. The Epicenter-based business has joined forces with Modality Partnership, who are an award-winning GP super partnership with a reach of over 12 million UK citizens. SKC Game Studio specialises in emotionally intelligent, multilingual AI avatar platforms, and their 1956 Individuals platform brings together a lifelike multilingual interface with a secure workflow automation engine that can securely orchestrate bookings, triage, referrals, and multi-team task management. Now, I love this area, as actually 25 years ago I worked on avatars for BT Wireless as part of the BT Cellnet 3G launch suite of apps. So we'll definitely have to invite them onto the pod to delve a little deeper into that one. Moving on. Two tech giants in ARM and NVIDIA are coming together to power a fresh wave of intelligent machines across global industries. Dipti Vachani, who's SVP and GM of the automotive line of business for ARM, said that across industries, intelligent machines were rapidly evolving. Vehicles are becoming AI-defined platforms capable of automated driving, and robotics is entering a new phase where humanoid robots, autonomous mobile robots, and smart industrial systems are expected to perceive, reason, and act in real time. Vachani said that intelligent machines require compute platforms that prioritise safety whilst delivering a combination of data centre class performance, scalability and efficiency. This is where NVIDIA's edge compute platform, NVIDIA Drive AGX Thor and Jetson Thor comes in, which use ARM's Neuroverse as the CPU foundation. So that's definitely a partnership to keep an eye on. Next, Cambridgeshire chipmaker Paragraph has raised $55 million in a new funding round, but claims that it almost ran out of money waiting for the UK government to clear $35 million of that investment, which came from UEA Sovereign Wealth Fund, Mubadala. CEO Simon Thomas has told the Times newspaper that the company was left hanging 2 weeks from running out of cash because of the red tape. Mubadala acquired 12.8% of Paragraph in the funding round, but Thomas warns that some companies might be forced out of business if they face similar clearance delays. Paragraph chips are made of graphene and can be used and deployed in multiple environments, including advanced electronics, energy plays, and medical devices. Okay, so that's this week's local tech news. Now to today's interview, where Faye meets Seb Lessware, CTO of 1Spatial.
Welcome, Seb. It's great to have you with us today.
Thank you. Good to be here.
So we're going to talk about you. First of all, you started out in cybernetics and computer science. And as James put it, before AI was even a thing. I'm not entirely sure that's entirely true, but it sounds quite nice. You're now CTO at a geospatial company. So tell us a little bit more.
Yeah, well, so like you say, AI has sort of been a thing since the 50s, but it wasn't really a big thing. And cybernetics appealed to me. I did my A-levels and I didn't know what I wanted to do, I think something technical. I'd done physics, maths and art, so there was a technical side to it. And so I looked through the list of all of the university courses available from whatever it was, anthropology to zoology, and a couple I stumbled across sounded interesting. Cybernetics was one of them, and artificial intelligence was a course you could do in Brighton. And so I picked cybernetics. It was a range of things, but it was some software, some hardware, some robotics, control systems, and AI was part of that course. We graduated right at the end of one of the AI winters, where it was interesting, but nothing that practical. Actually, just after that, it was starting to pick up from a theoretical point of view. So it's been really interesting seeing the evolution and massive hype cycle of AI at the moment.
Yeah. And what do you think of that hype cycle? I mean, it really is it's like everything gets labelled, URLs get labelled. I mean, it literally is crazy. And like you say, it's been going on for a long time and will continue.
Yeah, exactly. And it's a mixture of, it's trying to sort the signal from the noise. So there's definitely huge potential and interest there. The thing that really accelerated it was large language models versus traditionally it would be more like machine learning, put numbers in, get numbers out and do something interesting with them. And the large language models makes it more accessible to people because you're dealing with language and using it in that way. And that's really accelerated. I read only yesterday, Gartner are now predicting the slope of disillusionment just starting, where we're sorting out that actually these use cases are practically beneficial and the other ones aren't quite yet. So we're seeing that willowing down happening. So yeah, you have to take the hype with a pinch of salt to a certain extent, but you can see the real value happening at the same time. And hopefully the interest will broaden beyond just large language models because there's a lot more potential there.
Yeah, indeed. It's making me smile, the Gartner hype cycle. I haven't heard that for a while. It does make me giggle, all the little wording and but it's so easily recognisable, which actually I'm going back to something you said earlier on, which is your A-levels. So physics, maths and art.
Yeah.
So, I mean, actually, like physics, there's quite a lot of art in physics. I know we in a previous podcast, we talked to the crystallographic business here in Cambridge. Yep. And that, actually, there's a lot of art in that as well. So why did you choose art?
Well, my dad was an art teacher, so maybe that had an influence. I just liked it and I was okay at it. Right. And I didn't really know what I wanted to do. Initially, I was thinking something sort of technical, but a bit design-based, maybe like civil engineering or architecture or something. I ended up more in the software side of things. But I think even in that, I knew I wanted to do something creative in a way that you're not stuck in a loop and you're always doing new things. Yeah. Some of the jobs I've had, before I went to university were things like working in, washing up or in a factory where at the end of the day, you get everything back into the state that it was yesterday morning. And you just it seems like a constant cycle, as opposed to something where you're always doing something new, solving new problems, evolving things. So from that side of things, even the technical aspect is creative in a way. And so I think it was just the fact that I didn't know exactly what I wanted to do, kept my options open.
Yeah. And that's always a good thing to any younger listeners in here. Do what you're actually passionate about at your A-levels and degree level, because the rest of it can kind of follow. Not if you want to be a surgeon. Obviously, that's not quite right. But anyway, swiftly moving on. So you do your degree, your career starts, you find yourself at 1Spatial. And actually, you've got a really lovely story within the organisation, because you start, and it's a bit like that creative process you've just talked about. You start as a software engineer in 1997 and you get to CTO level in 2019. So tell us about that journey. Did you envisage that you were going to be there for the pretty much entirety of your career so far? And was it that loop just kept going and gave you what you needed?
Yeah, so at the time, no, absolutely not. In fact, I've got a few colleagues who've been there just as long as me, some longer. So I don't know what it is about the company where that happens. And on the face of it, sometimes I think, does that show a real lack of sort of imagination or ambition? But what's kept it interesting is I've never done the same job for more than a couple of years, maybe 3-4 years. And it's always evolved. And it's not been a direct line from software engineer to CTO. I've gone into professional services, consultancy, product management. And that's helped to sort of broaden my experience and view of different things. So it's more of a zigzag around the company. And it's been a very organic thing. So I've never had, what's your 5-year plan? Where do you want to be in 5 years? Never had one of those. Never been able to answer it. I wouldn't now know either. But it's just as opportunities have come along, I've sort of said, why not? I never imagined as well when I started that I'd be doing things that don't involve just programming in front of a keyboard, like presenting. It was small things like the head of marketing back then said, we need someone technical to come along and be on a stand at a trade show. And I knew him because we used to play football together. He knew I could communicate okay. And it was things like that that started it. And then I started speaking to real people outside the business. And then they said, do you want to present at our user group conference? I never dreamt I would ever say yes to that. And I was like, I can't really say no. Absolutely dreaded it. But since then, I've presented more and more. And actually, I quite enjoy it now. And so I never imagined that I'd be doing those things. And each time you do something that you've not tried before or you're sort of wary of and actually think, this is okay. I can sort of do this. And I think what's helped from the CTO point of view is you're very much a generalist. You know a bit about lots of things. There isn't anyone who works in the organisation on the technical side of things who don't know more about something than I do, but I try and keep a very broad view of lots of things where possible.
I mean, in essence, you've had a portfolio career just in the same organisation, and what's wrong with that?
Yeah.
I think that's actually quite a good idea for certainly people in their early careers now. That you don't have to label a job as I'm going to be there for 2 years and then I've got to move on and do something else. Why, if you're happy, then why would you want to move?
Yeah, exactly. And even in that time, it's been sort of 4 different organisations as it's evolved. We've been in 4 different offices. So the organisation itself is always changing anyway. Yeah, like you said, as long as you're happy, you are able to learn new things all the time and you like the people you work with, then it's good.
Yeah. Okay, so let's talk a little bit about the company, and I think I might dig back into some of those things later on. So I understand it was Cavendish Labs spin out in 1969.
Yes.
And then, interesting fact here that I hope is true, you were the first company on the Science Park.
Yeah.
Is that true too?
That's true.
So tell us a bit about the history then.
Yeah, so it was the high energy physics department at Cavendish Labs, the world-renowned Cavendish Labs, and they essentially had mini particle accelerators, bubble chambers that you'd smash things together and see the results. The way that you record that and track it is on photographic film. You get the paths of all these particles spiraling away. And it'd be someone's job to manually capture the number and the angle of these particles as they spiral away. That's quite a manual task. It takes a long time to get the results, quite boring. So they built something physical to automatically do this. And this was pre-1969. It was so long ago, they called it Sweepnik because Sputnik had just been launched and something ending in Nik sounded high-tech. Yep. And it was using a laser to scan the film and automatically track the paths of these particles. And they thought, this is great, we can sell this to all the other high-energy physics departments around the world, spun it off and started on the Science Park as this company called LaserScan. That's a small market, high-energy physics departments, but the control of those lasers turned into all sorts of other, mostly hardware-based things. So things like printing money, high control of lasers. Huge displays where you could show things like maps by essentially controlling a laser and drawing it very quickly, or things like plotters and things like that. So lots of different ways of using this hardware. One of the things that were emerging at the time as well is organisations like national mapping agencies, Ordnance Survey, were going from manual to digital techniques, which is a huge saving in time. So instead of having to re-scribe a piece of glass, you can store it digitally, make an update, print it again. So suddenly they had a need to digitize all their paper maps into digital data. And so this hardware was used for doing that, scanning maps, turning into digital data. And that's how we got into digital spatial data. And we then turned to the software that helps you manage that data and working with companies like the Ordnance Survey or organizations like the Ordnance Survey.
Okay, great. Thank you for the intro. And I want to come back and talk about some of the things that you actually specifically do now in 1Spatial in a moment. Just finishing off my Cambridge kind of loop. So you're still on the Science Park?
No, we moved to the business park. Now we're in Waterbeach because everyone's hybrid.
Yeah. Okay, that makes sense. But you've stayed in Cambridge. What kept you here? Just because the staff are here and some of your colleagues have been with you for 20 years here?
Yeah, exactly. There's a certain amount of inertia from just people here, but also there's it's a nice environment. It's a nice city. There is lots of technology skills around for recruiting, and we've got other offices in other countries, and we have people that work remotely around the country. But yeah, Cambridge is sort of the nice balance of you're close enough to London, but also other parts of the country. It's a good place to live and work.
Yeah, and we've seen other geospatial companies start popping up in Cambridge as well, certainly over the last decade. How has that been? Are they following what you do? Or are you all doing slightly different things? Do you all collaborate?
Yeah, so it's a mixture. So sometimes we compete. We tend to collaborate more because we've got our own specialisms. So, for example, Esri have been on the Science Park for a long time. Not their head office, but they've got an office here. I think they've moved into town now. But 20 years ago, we'd have been competing with them. Now we're partners and we work together because we found our specific niche. And same with these other organisations. Because geospatial is fairly small market, you come across people. Sometimes you're competing, sometimes you're partnering. Often you just coexist in the technology ecosystem.
So tell us a little bit then about the market. How buoyant is it? What types of things are really starting to take off?
We talked about organisations like the Ordnance Survey, and they've moved from producing maps, paper maps that people would look at, to storing the data to produce those printed maps, to suddenly actually this data is really useful because we can automate analysis with it. We can do analytics. People who take this data can work out where to put stores, or when they're building new shops, or working out where's the best place to put a solar farm and town planning and a million different use cases. And so that shift from this is information that someone's going to look at to this is data that we can do analysis on is used in all sorts of other industries. So like, for example, utilities companies, their job is to move gas or electricity or water or data, but they have to maintain the assets to do that, and they need a record of where those assets are. And that spatial data of where those assets are and all the non-spatial aspects, so what's the diameter of this pipe and what's the material, is all used for maintaining those assets and predicting load and working out where to repair and do predictive analytics, but also the downstream work of, well, actually, if we're going to start to do things like smart cities and predict who's going to plug in their electric cars and have solar panels, and where's the need for the power, and how do we expand, and where's the best place to develop, all needs that sort of information and data to be coherent and good quality. And so we've seen that need spread from national mapping agencies to utilities, transport, all sorts of government projects or private organisations who use that data not because they're a data provider company, but because they need it to maintain the things they do, like manage their assets.
And that's really where 1Spatial comes in, right? So it's about understanding that data, having the insights into it, making sure it's up to date, all of those types of things. So tell us a little bit about what it is that you're offering.
So our speciality is automation of data management, essentially with a focus on the spatial side of data. So people will receive or capture or take data in from a whole variety of different sources. Sometimes they're structured data sources, so someone's captured a point or a line or a polygon representing something in the real world. Sometimes they're unstructured, so it might be a LiDAR scan or a aerial imagery, which is just a set of pixels. And then they'll take that data and do stuff with it, combine it with other data sets, check it's good quality, and then produce some output, which might be analytics results, or it might be they're selling the data. And so we sit in the middle there, automating the processes of checking the data quality, flagging up things that aren't right, automatically integrating different data sets together to get a better result, inferring where there's missing data. So it's that whole data improvement and data quality. And when we started doing this work 25 years ago, we sort of did the whole stack. So we did a thing where you store your data, and then the data processing, and then a user interface that you could sit in front of to do the analytics. And actually what we found is there was competition coming in at the data storage, because relational databases like Oracle were letting you store spatial data, and they were very good at the data storage and the backup regimes and all of that. And at the front end, user interface, there are other companies like Esri who are very good at making user interface for people to sit in front and click buttons. And so we focused on the middle bit, which is doing clever things automatically with that data. That's how we've evolved into that.
Yeah, no, I mean, it's really, really interesting, isn't it? And you've talked about all of the different types of use cases. Where do you think it's going to go next? What do you think is the next? And actually, when you were talking earlier on, digital twins pinged to mind. And now I was a little bit like, is that the same as the AI conversation at the top of the call, where it's like a lot of it is hype? And I know from working with CW an awful lot, there's a real split of people who think digital twins are brilliant and people who think that it's just another hype again. So are digital twins reality, and where do you see the new use cases going in the future?
Yeah, digital twins, there's certainly an underlying reality to them. It feels like it's a name given to something that people were doing, but maybe not very much. And when I first read the definition of digital twins, it was a digital representation of the real world or something similar. I thought, well, that's just data. All data is a representation of the real world. The key thing with digital twins is some live measurements from sensors about how it's performing right now. So, for example, we work with utilities and they'll have a record of their data, but typically that's the record of the data as you put it into the ground 20 years ago. That's a birth certificate. That's not a digital twin. What they need to know is, actually, is this pipe got clogged up now? Is this cable got dodgy connection, and therefore the current flowing through it is compromised? So by putting sensors on your network, you're getting a real-time readout of how this is actually performing. And that's an example of a digital twin. You can then make decisions based on reality. What we've seen is that concept has spread from individual components like the electricity network to a broader view of electricity networks, solar panels, how are they performing, what's the weather like, predicting where that's coming in, connecting that up to another similar concept, smart cities. That's another sort of buzzword, which is, well, can we join all this stuff up to do a bit more intelligently? So what time is the train going to come in? What's the congestion going to be like? What's the draw? What time are people going to come in and park their cars and plug them into the network to charge them? All that sort of thing. And so those are good examples of where digital twins we see evolving to do just more intelligent automation. And it's the same with AI techniques. Is the thing that gets people excited about it is it allows you to do automation in a more intelligent way. And automation is always something that we focus on. We spend time configuring things to allow it to do things automatically, and we use AI techniques where that's relevant. But also, organizations who want to use their data to feed AI processes and train AI models need to make sure that data is clean and consistent and unbiased. And so that's another area where we get involved in, is making sure the data is clean and consistent and unbiased.
So I'm being devil's advocate a little bit here, because I'm in my deep recesses of my brain. I'm remembering 2 decades ago when I was in IBM, we were talking about smart cities and all of those things that we should be able to track, but we're not. We're still, some maybe, but we're not getting that joined upness. So why do you think that is?
I suspect there's a bit more than is apparent, but because it doesn't come under the banner, this is a smart city, we are now a smart city, here is some smart city software, it's sort of hard to track. It certainly is always slow. So you get, the classic, hey, everyone, we should do smart cities. Yes, that sounds like a good idea, but then no one actually does it. But what you see more and more is that the digital ecosystem of APIs making data available, software talking to software, maybe with AI agents able to mediate that, but not necessarily. So, a simple example is, I can go to all sorts of websites. I need to buy something for my car, I type in my number plate, it knows exactly what I need. That's a very simple example of an API, or I can type in my number plate, when's my MOT due. That's an example of a data set being made available of every car's number plate and its make and model that organisations can use to plug in and provide that service. Doing that for data more widely helps to create those automatic systems that talk to each other. And so you do see it more and more, people making data available through APIs to solve problems. And the more you connect these things up, the more you inadvertently end up with a smarter city.
Yeah. Okay, so I feel I've curveballed us off to a different bit of the conversation then. So your predictions for what you would like to see and the types of things that you're progressing on now within 1Spatial?
Yeah, so we always talk about data quality and data improvement, make sure your data's managed well, because that's a fundamental aspect of all of these processes. And what we've seen happening is a shift from software being the important thing to the data being the important thing. You can use all sorts of bits of software to manage the data, but the thing you need to keep and maintain and respect is the data at the core of it. And that data is used not just to show to people for them to make decisions, but to feed these automated processes. The AI thread that happens in parallel, for example, if you take that as one of the buzzwords, in geospatial world, we see AI being used in two areas. One is large language models. Same with any industry. Here's a way of taking input from a person and inferring what they mean and doing something for them. The maybe more interesting side of things is the machine learning aspect. And in geospatial, one of the focuses of machine learning is taking images, so aerial images, and automatically generating structured data from that, or doing analysis directly on the imagery. A lot of the talks that you see about geo AI or AI in geospatial are about, look, we can take these pixels and make some inference. That's a little bit boring, or at least you sort of see it done over and over. We've detected, tree loss automatically, which is great. It's really important, but it's the same story over and over. What would be more interesting is if we get more focus on the vector data, the structured data, and using that for machine learning. It'd be great to be able to create not a large language model, but a large spatial model, which isn't just talking about pixels. And pixels are straightforward. Any pixel is surrounded by 8 others. Whereas vector data that represents the real world has got a lot more potential to generate insights. So what I'd like to see, or I hope to see, is more focus on structured data and machine learning processes to automate things from structured data. And that's something that we're doing, but we'd like to see that done a lot more widely.
And surely that has to involve more people as well. There's got to be a limit to how much you can do. So that's the collaboration piece that comes in again. It's more people coming together to be able to achieve more things, right?
Yeah, exactly. Coming with use cases, well, actually, we think you can solve that in a certain way, or coming with data to say, can we use our data and train it in this way? And it could be some of the things that we do are things like inference. So there was a legislation 10 plus years ago where sewage companies, water companies took responsibility of the pipes from your house to the mains. It used to be local authority or the homeowner. And so they suddenly were responsible for all these sewers, but they didn't have the data to go with it. And then they get fined by the regulator for not knowing where their data is. So rather than go out and have to survey every single property, automatically inferring where we think this would be based on talking to engineers who say, actually, I can guess that that's a Victorian house. There'd be one there and one there and one there, and we can turn that into rules. So inferring missing data is an example where the problem wasn't obviously a structured geospatial data problem, but it's something that could be solved with that. So it's finding people who have problems, seeing how to solve them, and then using their data to help solve their problems, just using some knowledge and technologies that can help them join the two together.
So there's a lot of opportunities out there. And you can tell just by having the conversation with you that broad spectrum of expertise means that you're not just looking at it from an engineering point of view. It's a use case, it's a business. Do you know what I mean? There's all those different things. So you've done loads of podcasts and interviews and talks and those kinds of things. Is there anything that's kind of keeping you up at night that like really frustrates you about this, that we're just not ticking over from a technology point of view?
There's things that keep you awake at night because you have to worry about them, like, cybersecurity. You've always got to be vigilant and keep pushing things. And then there's things that are maybe frustrating because they don't get the right focus. And I think the aspect I talked about before, which is using machine learning techniques on the vector data, not just the unstructured imagery, I think that we're missing a trick there. As an industry, we should be doing more of that. Also, one of the problems with geospatial data is because it's specific software and typically specific skills or people with that experience, it often gets pigeonholed as that thing over there in the corner, and it's often not considered in the same way as all the other data flowing around the business. So handling things in a consistent way for all your data across the business, including your geospatial data, just makes sense. Otherwise, it's short-sighted and you're missing a trick. So we often see that as the use of spatial data broadens into organizations who aren't spatial data organizations, is educating them on how to treat this stuff as part of their fundamental data and not just some sort of side hustle that they're doing at the same time.
Yeah. And is there like an association or something like that, or do you take your role as a company quite seriously in helping to educate people?
There are loads of associations. So there are things like the Association of Geographic Information and the OGC, the Open Geospatial Consortium. So there are national ones, there are international ones, there are standards bodies. Often these things get sort of absorbed into ISO standards. So we don't need any more associations. I think we're good for associations. And typically what you see is as well, often these big committees, when they're defining standards, sometimes the reality of business sort of sweeps them up. So we were working with the OGC 20 years ago, defining the first web mapping standards. So mapping on the web before Google Maps came out. And then Google Maps came out and said, yeah, these standards are cool, but here's a way of doing it really, really quickly. And there's all sorts of compromises, but actually as a user experience, it's just much slicker. And we all went, okay, fair enough. You cut some corners, make some compromises, and it's just easier for the user. And so sometimes the standards get swept up and overtaken by just commercial or at least technical reality. But there's other occasions where if you don't have those standards, people go in all sorts of different directions. There's no interoperability. So, for example, we're doing a project at the moment called the National Underground Asset Register, which is everything that you could hit with a digger is available in one place to see what's there, because people die or electricity gets cut off, comms get cut off. And so that's a sheep herding project where you've got 700 organisations, all with different things under the ground. They're all similar themes. So there's gas pipes, and there's electricity cables, and there's protected tree preservation order routes. They've all got the same sort of thing, but they all record that data in a completely different way, different structures, different ways of encoding it, different data formats, different ways of encoding what the type of material is. And we're helping to get that into a single consistent model. Now, that model happens to be an international standard called MUDDI, M-U-D-D-I, and NUAR is one of the first projects to really go for it on that standard. So that helps having an agreed way of everyone working together to do things. You just have to be aware of sometimes the standards is the best way, and sometimes reality takes over and other things come to the fore.
Yeah. Wow, what a mapping exercise that is.
Yeah, I mean, that's a big one in terms of just the range of data. And the important thing with that is if you take the data and put it in one place, within 30 seconds it's out of date because things are constantly changing, new pipes being laid, fixed, modified. So data currency is key there. And Ordnance Survey say the same thing. They say we're basically a data maintenance company, that keeping the data up to date is the key thing. So here with the NUAR system, it needs to be kept up to date constantly. So there are 700 organizations and they master the data. They're the ones who keep it and look after it. But it needs to be automatically updated in this central place. So often what we get involved in is that sort of data flow where you agree where it's being mastered, and this is master data management. That is the definitive source for it. And this is a copy. And as long as we acknowledge that as a copy, and as long as we keep it up to date, then that's fine. It's available in one place. And so the tricky thing is the 700 different organizations, timescales, personalities, and their sort of desire to take part, and sometimes competing with each other as well. And that's the tricky thing with that sort of big project.
Yeah. That lovely word, co-opetition, comes into play there, doesn't it? Seb, it's been brilliant. Thank you so much. I feel like I've learned a few things. And do you know what? It's also really nice to hear from a company that has been around for, 2.5 decades, because we talk to a lot of people that are the emerging, the brand new, the fresh ones that they may get bought out. Some of them may fail, but actually you've been just steadily carrying on. You're recognised as one of the Sunday Times best places to work, which is absolutely brilliant. So thank you so much for coming to join us today, and all the best at 1Spatial.
Thank you, Faye.
Today's show was produced by Carl Homer of Cambridge TV and supported by our media partner, Business Weekly. The Cambridge Tech Podcast is available on all major podcast platforms and on cambridgetechpodcast.com. If you've enjoyed this podcast, please give it a 5-star review. It'll really help others discover the show.